This is the second half of the video. The first half of the video was setting up Ohm's law and doing our total resistance. So it's important to know when you're doing this, when you're calculating the total resistance of a circuit that has both series and parallel, which is the circuit that we did, is always to calculate the parallel section first, then the series section. And that's what we did with this calculation. So, whoops, wrong one, this one. So, so now let's connect to, let's see here. Here we go. So here is our parallel first, then series. So the parallel part is these two here, and then my series is this entire section and this. So we have this entire section that came down here, or our RTP. So we have our RTP plus our L1, and that's what equals 120 ohms. So then what we need to do is, and I'm going to show you on this next slide. So what we have here now is, so we have our, let's see here. Let me go to, there we go. That's what I wanted. So voltage versus amperage. Whenever you're in a series circuit, your amperage is all the same and your voltage is different. So each component individually is absorbing a different amount of voltage, but the amperage going through the system, since it's one circle, is all the same. So then in parallel, your voltage is the same across the parallel circuit and the amperage is different. So when we're calculating, we're adding a lot more to our calculation because we have to now find out information about a series circuit and a parallel circuit at the same time. So when we're calculating voltage and amperage of a circuit that has both series and parallel, we use the RT, which is what we already figured out, to solve the amperage for the series circuit. Okay, so we're going to now solve for the amperage for our L1. Let's go back here so you can see this. We're going to calculate the amperage of L1 and let's call it TP. So our RTP, which is our total parallel circuit, okay? So P, if you will. And so then what we have is, let's go back to our slide here. So then we're going to use the amperage to find the voltage of the parallel section and the series components, okay? And then the last thing we're going to do is you're going to use the voltage for the parallel section to solve for. So what we want to basically do next, okay, our next step is to create, if we come in here, okay, I'm going to go ahead and come down here. Now what I want is my current for my whole system. So my total current. So my total current is based on this, this number, which is our total resistance of our system. So RT, we have V over R equals I, okay? So now what I'm going to say is I'm going to say 9 volts divided by 100.9091 ohms equals. So I'm going to bring my calculator in here. I'm just gonna, I averaged it out. I mean, I had the whole number, but that's okay. So we want 9 divided by 120.9091. Okay, so now we get a number of 0.07444 amps. Okay, go ahead and single underline that. So this is my total amperage, and what I need you to understand is this is the amperage of L1, and it is the amperage of all of this, not R1 and R2. This is the amperage for this entire system. So this is the amperage of this 90 ohms, and this is the amperage of this 30 ohms, okay? So the very next thing I'm gonna do is I now need to find voltage. So I told you that voltage is different, amperage is the same in series. So we're still calculating our series, and our series is based up of L1 and our parallel circuit, okay? So now I'm gonna say E equals, and you know what? I'm gonna say E around L1. That's what I meant to do. E around L1. E around L1 is, now we want voltage. So we want I times R. So I T times R, or L1. Actually, I'll do this, L1. No, R 30. Okay, so R equals, and then we have 0.07444 amps times 30 ohms equals, so I have my number right there, times 30 is 2.233 volts. Now, the reason that this is important is I now need to find, so my amperage is the same between this and this. My voltage is going to be the same here, but my amperage is going to be different. So the next thing I need to do is I need to say E of, and I'm going to say E of P. So E of my parallel circuit. So I'm going to say I T times R equals, which is going to be my I, which is 0.07444 amps times my total of my RTP, or my total of my parallel circuit here. So times 90.9091 volts. Ohms. Come on, Mr. Ruggie. Ohms. Equals. So now, this time I'm going to say 0.07444 times 90.9091. So now that I have 6.767, let's say 73 volts. Okay, now the reason that number is important is now I need to put this back into figuring out here. So this has 6.7673 volts, so does this. Now I need to figure out what the amperage, or the amperage of them is, okay? So now I'm going to say I, or current, or amperage, I of R1 equals And down here, I'm going to do R of R2. So I of R1 is going to be I equals V divided by R. Okay, so V divided by R equals, and I'm going to say this volts, 6.7673 volts divided by, and I'm going to say right here, what's R1? R1 is 100 equals, and I'm just going to do this for you, divided by 100. I know this is simple, but sometimes people have a hard time dividing by 100. So this is 0.06767. 0.06767. Okay? Amps. Now, we're going to do one more calculation, and then we're done. So then now, we're going to say same thing. So I R2 equals V over R, same thing, which equals 6.7673 volts divided by, I forgot to put ohms there, 1,000 ohms. Okay, so now this equals 0.006767. Okay, now here is the important part. This plus this should equal this. Okay, that's our total amperage for this parallel circuit. Okay, so we're going to say we're going to say 0.06767 plus 0.006767 and 0.074437, which is 44. So that is equal to this. Okay, I'm not going to do that down here just because I think you guys got the idea. All right, that's all I have for my video. Good luck doing some calculations, and thanks for watching.